Now we get to one of the trickier parts of this conjugation stuff from this chapter. So what I want you guys to do now is pause the video for a second and look at this structure and say, what is the hybridization of this carbon atom here? Also, what is the hybridization of this carbon atom here? So think about that, make your decision, and then restart the video. All right, so how do we figure out hybridization? We usually go by the number of groups. So the number of groups around this carbon would include 2 hydrogens, a carbon, and a lone pair. That would be 4 groups. 4 groups would each individually need a hybrid orbital, which means that it would have to be sp3 hybridized. So that carbon atom in this structure looks like it's sp3 hybridized. What about over here? Well, in this structure over here, the groups include a hydrogen, and a carbon. Only 3 groups. 3 groups require 3 hybrid orbitals, which would be sp2 hybridized. So we have a little bit of a contradiction here. This one says it's sp3, this one says it's sp2. So what is the answer? Okay, so all that being said, if we are showing the movement of these electrons going from this resonance structure to this resonance structure, that means that it's conjugated, right? Because resonance shows conjugation. So for that lone pair to be conjugated, what kind of orbital does it have to be in? Did you answer that yet? What kind of orbital does it have to be in? What is the definition of conjugation? We've been talking about it, but what is it? The definition of conjugation is the overlap of 3 or more p orbitals. So for this to occur at all, for us to have the ability to show 2 resonance structures, this lone pair isn't in an sp3 orbital, it has to be in a p orbital. So it turns out that that's not true, that hybridization one. If we look at this and we know that it's able to do this, for these electrons to be able to be delocalized, they have to be in a p orbital. So in reality, it's sp2 hybridized, and then the lone pair is in a p orbital. That's kind of the trickiest part of this hybridization stuff. And on the bottom of the page it says, if a resonance structure shows that an atom, so an atom like that carbon, has any pi character, and it does, right? In this structure here, this carbon has a pi bond, so it has pi character. You must assume that the hybridization is adjusted accordingly. So yeah, it looked initially like that was sp3 hybridized, but here we know it has to be sp2 hybridized because it has those electrons in the p orbital. So that's I'd say the trickiest thing about this hybridization stuff is when we do have 2 resonance structures, being able to determine what is the hybridization of an atom.